what I was getting at when I was talking about the different types of transformations, where we have our translations, we're going to talk about reflections, rotations, and dilations. The first three, translations, reflections, and rotations, are a specific type of transformation, okay? They are called rigid motions, okay? If you think of the word rigid, okay, think of the word rigid and what it means. What does it mean to be rigid? Any takers? What does it mean to be rigid? And maybe it's a word that you haven't come across as up until your 10th grade years. But what do you think it means to be rigid?
Are you meaning in like a real world definition or in math?
In real world.
Rigid, something that doesn't move very much, I believe.
Okay, so not moving very much, maybe immovable. What about unchangeable? Do you think something that's rigid is unchangeable? Or it's not very changeable, it doesn't change easily?
Yes.
Okay, so that real world definition applies to this math definition as well, okay? So rigid motions are motions that essentially preserve shape and size. So they're motions that don't change the pre-image, okay? They don't change the pre-image. They just change where it is. They move it without changing it, okay? Think of like if you ever, well, this might be a little bit difficult for you guys, but if you ever seen like in movies or maybe in real life where literally someone's moving a house, not that they're moving to a new house, but they're physically moving a house, like they took their house and they put it on a trailer, like a big truck, and they're like moving their house to a new lot, okay? That would be like a translation. They're literally moving their house, but their house isn't changing, right? The location of the house is changing. So rigid motions are transformations that preserve length. So how long things are stay the same, and angle measure. Okay, they preserve length and angle measure. So meaning that if I had a triangle, right? If I have this triangle here, triangle ABC, I translated it to A prime, B prime, C prime. Notice these angle measures did not change, and the length of the sides did not change. CB was 3 places long, it's still 3 places long. AB or AC was two places. A prime, C prime is still 2 places. So the length of the sides and the angles don't change. Just the position of where the shape is changes. So rigid motions, they preserve length and they preserve angle measure. Another name for rigid motions is isometry. Okay, isometry. No. Okay, isometries. And the rigid motion maps lines to lines. So if it's a line, it ends as a line. If it's a ray, it ends as a ray. If it's a segment, it ends as a segment. If it's a triangle, then it ends as a triangle. If it's a circle, it ends as a circle, and so on. So the shape is preserved. The size is preserved. All that changes is where it is. Okay. So that's the main thing I wanted to talk about. We will come back to compositions. I promise you we're going to come back to this. Okay. And it might be in a few lessons, but we're going to come back to compositions. Okay. So hang tight for this second part or this last part of 4.1. We're jumping around a little bit, but I feel like hopefully it'll help a little bit more. Okay. So we will come back to this. So don't get rid of your 4.1 notes quite yet. All right. let's get started with our 4.2 notes. We are talking about reflections. So here's our objective for the day. Our objective is I will be able to perform reflections across different lines and identify lines of symmetry. I will be able to perform reflections across different lines and identify lines of symmetry, okay? This is our goal for today. We're literally going to be talking about reflections. Give you guys 30 seconds to write that down. Okay, so reflections. A reflection is a transformation that uses a line like a mirror to reflect a figure, okay? That mirror is called the line of reflection. Line of reflection, okay? All right, we don't need to worry about this. We're gonna go straight into exploring some of our stuff there, okay? So we have our mirror, we have our line of reflection. Now, usually our line of reflection is identified for us, okay? So we're gonna explore some ideas here. It says graph triangle ABC with vertices A at 5,2, B at 7,6, and C at 9,5. Okay, and its image after the reflection described. So each one of these, notice at the top A, it says in the x-axis. For B, it says in the y-axis. Okay. Now, we're going to learn a few things here. Okay. So first thing we need to do though is we definitely need to graph our triangle here, triangle ABC. So we are going to go ahead and take A at 5, 2. So A is at 5, 2. So here's 5 on the x-axis, 2 up here for the y. So here's my A. Okay. B is at 7, 6. So 7 for the x right here, and 6 for the y. So 1, 2, 3, 4, 5, 6. Here's B. Okay. And then C is at 9, 5. So here's 5, 6, 7, 8, 9, and then 5 up. 1, 2, 3, 4, 5. Okay. Okay. So here, here, and here. Okay. So there's our pre-image triangle ABC. Now, in this first example, they want us to reflect, okay, and find its image, reflect in the x-axis, okay, reflect in the x-axis. That means they want us to reflect across the x-axis, okay? This is our line of reflection right here. Make that a little bit darker here. That one. Okay, there's our line of reflection. Now here's the beauty. when we reflect something like across a line of reflection, there's something cool that happens in that the reflection is the same distance. Okay, the reflection is the same distance from like, so this point is going to be the same distance to the line of reflection as the reflection is. So if, let me clarify. So if I want to reflect point A, right? Here's my line of reflection, my x-axis. I can count very easily how far I am from the x-axis. So for A here, it's 1, 2 away from the x-axis, right? That's 2. So then that means starting from my line of reflection, if I count 2 in the opposite direction, I will get to A prime. So if I do 1, 2 in the opposite direction, this is going to be my A prime. Okay. And I can do the same thing for B and C, where I count the distance that B is from my line of reflection, and then count the same distance in the opposite direction on the other side of the line of reflection, and that'll give me my image of B, which would be B prime. So if I take B, I have 1, 2, 3, 4, 5, 6 to my line of reflection. So that means if I start at my line of reflection here, this is 0. So 1, 2, 3, 4, 5, 6 in the opposite direction, this will be my B prime. Okay, so this is also 6 from my line of reflection. The same thing I can do with my C here. 1, 2, 3, 4, 5. Hold on. 1, 2, 3, 4, 5. Yep. Okay. And then count 5 in the opposite direction for my line of reflection. So 1, 2, 3, 4, 5. This would be my C prime. So then if I connect my triangle sides here, okay, these two triangles look like mirror images of each other. Okay, if I hold it like this, we can see that mirror image happening there. So the distance of each point, okay, to the line of reflection is the same on each side of the line of reflection. So the distance here should be the same distance as its reflection. The distance from this point to the line of reflection is the same as the line of reflection to the mirror image. So same thing here. Okay. So now let's list our points. Okay, so where did A prime end up? A prime is now at, so I want the coordinates for A prime, right? I want to put them right here. I want A prime, B prime, and C prime. So if I take a look at A prime, I have 1, 2, 3, 4, 5 in the X category. And then down 2, so that's going to be -2 now. Okay. B, I have 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6 down. So this is going to be now 7, -6. And then I have for C, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5 down. So 9 to the right, 5 down. So 9, -5. Okay. So let me ask you a question here. What happens to the X and the Y coordinates when you reflect each point in the X axis? Okay. Look, compare the points here. A to A prime, B to B prime, C to C prime. What is a pattern that you're noticing here? Okay, go ahead and write it in the chat. What's the pattern you're noticing? Good, Andres. How did it change? Okay. Write down your pattern. Good. Write down your pattern in the chat, guys. I'm looking for participation here. Lack of participation will result in loss of participation points. Good word, Michael. Good, Jasmine. Good, Gabriel. Last call for participation points. Thank you, Samson. No need for shouting, man.
Sorry, I was on caps lock.
All right. So, thank you guys. All right. So you can see here, right, as many of you are saying, okay, specifically, we had some opposites happen, but we specifically saw opposites in our y coordinate, okay? So when we reflect in the x-axis, when we are reflecting in the x-axis, our y coordinate changes its sign. So the y coordinate changed its sign, right? So it went from positive to negative in this situation, okay? But what happened to the x coordinate? Did it change? Did the x change? What happened with the x? Okay. Anyone? Anyone? Other than Mariel? Mariel, thank you. Okay. Our x did not change, right? It stayed the same. So our y coordinate changed its sign, but the x stayed the same. Okay. Our y coordinate changed its sign, but the x stayed the same. So when we have a point reflected in the x-axis, right? Then the image point, if we start with xy, this is a rule that we're writing. If we start with xy, the x stayed the same, but our y changed its sign. Okay, this is for the x-axis. Okay, so when we reflect in the x-axis, every one of our points, the x stays the same, the y changes its sign. Okay. All right. Now let's see what happens if we reflect in the y-axis. Okay. So same triangle, A, B, and C. So we're going to plot those points again. 5, 2. Here's A. 7, 6. Here's B. 9, 5. Here's C. My triangle. Oh God, that was really bad. Okay. There's my triangle ABC. Okay. But now we're doing the reflection in the y-axis. So here's our y-axis here. Okay, that's the y-axis. That means this is our mirror now. So each one of these points is looking at this mirror and being reflected across this mirror. Okay, so we're looking this way now. But the same rule applies. Okay, the distance that a point is from your line of reflection, it's the same distance that the reflection is from the line. Okay, so if I count for A here, now I'm counting to this line of reflection. So I'm counting this way. So I have 1, 2, 3, 4, 5 for A. And then I'm going to count 5 exactly the opposite direction. So 1, 2, 3, 4, 5. Here's my A prime. Okay, that's my 5 right there. Okay, so for B, 1, 2, 3, 4, 5, 6, 7. So now I count 7 in the opposite direction. 1, 2, 3, 4, 5, 6, 7. Here's my B prime, my image. Lastly, I have my C. Okay, this is gonna my pre-image, counting 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's a 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my 9 there. Got the 7 there. C prime right there. So if I connect my dots for my triangle, my points, sorry. There's my mirror image of that triangle across the y-axis. Okay. And if I write down my points now, okay, my A prime is at -5, 2. My B prime is at -7 and 6. And my C prime is at -9 and 5. Okay. Look, take a look at those sets of points. Okay. Compare A and A prime, B and B prime, C and C prime. What do you notice? Which coordinate stayed the same? Which coordinate changed? Not x-axis, x-coordinate. Good, Maya. Good, Jasmine. Good, Andres. Good, Maya. Very good. Thank you, Andres. Very good, guys. Last call for participation here. All right. Thank you, Andres Leon. Okay. So as we can tell, as many people mentioned here, in this situation, we go from 5,2 to -5,2, 7,6 to -7,6, 9,5 to -9,5. So we can see that when we reflect across the y-axis, okay, our y coordinate stays the same. The y stayed the same, and the x coordinate changed its sign. So in this case, the x is changing its sign, the y is staying the same. Okay, so our y, oh, wrong color. Our y stays the same here. So when we reflect across the y-axis, when we reflect in the x-axis, wow, scratch that, ignore me. when we reflect in the y-axis, okay, our y stays the same, but our x-axis, x-coordinate changes the sign, okay? X changes. So if we want to generalize this a little bit, we can say that whatever axis we are reflecting stays the same. So when we reflect in the y-axis, the y stays the same, x changes. When we reflect in the x-axis, x stays the same, y changes. So whatever axis we're reflecting in stays the same, the other coordinate changes its sign, okay? So if we take a look here and we follow these rules, okay, these rules can help us figure out the coordinates of our reflection before we even graph our reflection. Okay, so let's take a look at this example 1. It says the vertices of triangle JKL are J at 1, 3, K at 4, 4, and L at 3, 1. Graph the image of triangle JKL after a reflection in the y-axis. Okay, so we have our pre-image here of triangle JKL. Okay, pre-image is at J is at 1, 3, K is at 4, 4, 3 is at 1. But they want us to graph the image after we reflect it in the y-axis. They don't want to see the original. They don't want to see the pre-image. They just want to see the image, the reflection. So we can do that by using this rule. We are reflecting in the y-axis right here. Okay, so we can use the rule for y-axis. So the rule for y-axis says that if xy is reflected in the y-axis, then its image is the point negative x comma y. So our y stays the same, our x changes its sign. So if our y's are staying the same, then that means my image, my j prime from j, my y will stay the same. So I'll still have a 3 for my y, okay? And then the k, same thing. I'm reflecting in the y-axis, so k is the same thing. My y coordinate will stay the same, so 4. My L is the same. My y coordinate stays the same, so it's a 1. All because I'm reflecting in the y-axis, right? But it says the x will change its sign. Okay, so the x will change its sign. So if it's positive, it'll become negative. If it's negative, it'll become positive. So over here, for j, my x is a positive 1, which means a reflection in the y-axis means it'll become a negative 1. For k, my x is a positive 4. A reflection in the y-axis means it'll become a negative 4. For L, my x is a positive 3. So a reflection in the y-axis means that it will become a negative 3. Okay? And then I can graph J, K, J prime, K prime, and L prime. So negative 1 and 3. Okay, here's J prime. Okay, K is at negative 4 and 4. So here's negative 4 and 1, 2, 3, 4 up. Here is K prime. And L prime is at negative 3 and 1. So negative 3 and 1. This is now L prime. So I can connect my points here to draw my image triangle. Okay. Can I get a reaction to this example, please? I would like to see a thumbs up if we understood the example. A thumbs down if we were completely lost on the example. And a yes if we're iffy. Okay, a yes is the iffy. So thumbs up means I understood the example. Thumbs down means I was completely lost in the example. a yes is a thumbs to the side, essentially. Okay, meaning that I understood it, but I have questions.
That's powerful because you were able to predict the new points of the reflection without even graphing it
Yeah, rules are great.
by using the rules.
Yeah. Okay, ladies and gentlemen, I would like a reaction from most people, please. Okay, thank you to Samson and Maya and Mariel and Leanne and Joshua and Jasmine and Callie, Andres and Andres. Okay. Literally just give me some sort of reaction. I gave you 3 options. Thumbs up. Okay. Thumbs up means I got this. It was a good example. I understood it. Thumbs down means I did not understand it. Thumbs to the side means I was there with you. I think I need another example. I might have some questions, but you got to give me something. Okay, I'm giving you something in between. Okay, thumbs to the side is the yes mark. So if you give me a yes, you're giving me a thumbs to the side. Okay, let's see. Michael, Kebra, Heaven, Caleb, Bethany, where y'all at? All right, thank you guys. Okay, so let's flip it over, see what we got on the back. Okay, we got a lot more examples on the back, I promise you. Okay, let's take a look at examples 2 and 3. Okay, wait. Okay, hold on. Okay, go back to the front. You guys asked me for another example, right? So let's reflect the same triangle. Okay, let's reflect the same triangle, but now let's do a reflection in the x-axis. Okay, so let's find, we're gonna call these guys double prime because we can't call them the same point. Okay, let's find J double prime, K double prime, and L double prime. Okay, it's called double prime because we have 2 of the little prime symbols there. Okay, so let's say we were reflecting our original pre-image, triangle JKL, right? Let's say we were reflecting that, but now reflection in the x-axis. Okay, reflection in the x-axis. Here, let me pick 2 different colors here. We can do green and orange to help us out here. Okay. All right. So now we're doing a reflection in the x-axis. The rule for the reflection in the x-axis is as follows. If xy is reflected in the x-axis, then its image is the point x comma negative y. AKA, when we reflect in the x-axis, x stays the same, the y changes the sign. Okay, So if you feel like you got this, I highly encourage you to do this on your own. And Andres is already on it. Okay. Andres Moreno is already on it. I encourage you to try to figure this out as I explain it for the rest of the students. So again, reflection in the x-axis, right? The rule is the x stays the same, the y changes the sign. So for this rule, our x stays the same. That means we are going to bring our x down because it's going to stay the same. So for each of these J, K, and L, my x coordinates will remain the same for J prime, K prime, and L prime. I'm sorry, J double prime, K double prime, L double prime. Double prime, that's what I'm saying, by the way. Okay, so my x stays the same. That means 1 stays as 1, 4 stays as 4, 3 stays as 3. Okay. Now for the y's, whatever my original y is, now is going to change its sign because of the rule. So y is a positive 3 for J. That means it'll be a negative 3 for J double prime. Y is a positive 4 for K. So since I'm reflecting in the x-axis, it'll now be a negative 4 for K double prime. Y is a positive 1 for L, so it'll be a negative 1 for L double prime. Good, Gabriel? Okay, so now we can actually take this and we can graph it. J double prime will be at, oh, I don't have these points. Haha. Hold on, let me see if I can extend this a little bit. Okay, at 1, negative 3. So 1, negative 3, 1, 2, 3, right around there. So that's going to be my J double prime. K double prime will be at 4, negative 4. So 4, negative 4. I'm guesstimating my spots here, but that's okay. It happens. L double prime will be at 3, negative 1. So 3 and negative 1. Here we go. L double prime. And here is the original triangle reflected across the x-axis now. Okay. I think my points were off due to the fact that I was trying to count them myself down here. So ignore the size thing. Okay. So we're just using the rule, right? We're just using the rule. All right. Okay. Let's take another idea of where we're at here. Okay. Are we doing good, bad? How do we feel? Give me a thumbs up or a thumbs down this time. Okay. So thumbs up. Oop, thumbs up or thumbs down. Okay, I only have 7 responses, which is not cool. Can I get some responses from other people? All right. Thank you to those of you that are responding. Andres Moreno, Gabriel, Heaven, Jasmine, Joshua, Kebra, Leanne, Michael, Maya, and I believe Ulysses. Thank you. All right, cool beans. So we have obviously more examples to do. So let's take a look at the back examples here. Okay, example 2 and 3, graph triangle ABC with vertices of A at 5,2, B at 7,6, and C at 9,5, and its image after the reflection described. Okay, notice these guys now. It says our reflection, our line of reflection is actually a horizontal or vertical line, okay? So our reflection is now going to be in the line N, which is x equals 3, or in the line M, which is y equals 1, okay? When you have a reflection across lines like this, your best bet is to use this process here, the counting process. Okay, that's what's going to save you when you're reflecting across random horizontal or vertical lines. Okay, because there's no rules for these guys. So if we take a look here, if we're graphing across x equals 3, this is going to be our line of reflection, right? Or our mirror. That's our line of reflection. So let me zoom in here. So first thing we want to do is we want to graph our pre-image triangle ABC. So we're going to do that really quick. Okay, 5, 2. I believe this is our same, yeah, it's our same triangle. 7, 6. This is our same exact triangle as from in the front. And 9, 5 for C. Okay. So there's our triangle. But now we are reflecting in the line x equals 3. Okay. So how do we draw the line x equals 3? Well, it's x equals 3. So on the x-axis, we go 1, 2, 3 for x equals 3. And we draw a vertical line right through x equals 3. So this is the line x equals 3. So how do we do that again? Since it was x equals, we went to our x-axis. We went to a positive 3. So 1, 2, 3. And I drew a line right through that x equals 3. So we are reflecting across this line right here. Okay. All right. So again, like I said, what's going to help us is counting, because this is our mirror right now, right? We're reflecting across this line here. So I want to know, where does A end up on the other side of this? So again, distance and counting is going to be our BFF here. So for A, I count the distance from A to my, from A to my line of reflection. So over here I have 1, 2. So for A, it's just 2. That means I'm going to go 2 on the other side of my line of reflection. So 1, 2. So my A prime will be right there. Okay, distance, right? That was a 2. All right, for B, I have 1, 2, 3, 4. So the distance from B to my line of reflection is 4. So I'm going to go 4 in the opposite direction. 1, 2, 3, 4. Here is B prime. Okay. Lastly, C. 1, 2, 3, 4, 5, 6. Okay. So from here, 1, 2, 3, 4, 5, 6. Here's C prime. Okay. Connect my dots. Oops, that was too much of an angle there. There we go. And there is my reflected triangle A prime, B prime, C prime. Okay. Let's do another example, shall we? We're starting with the same exact triangle. So we're going to start by drawing our pre-image of ABC. So at 5, 2, here's A. At 7, 6, here's B. And at 9, 5, here's C. Okay. Triangle ABC. There we go. Now, our line of reflection, we are reflecting in the line M, which has the equation y equals 1. Okay. Oop, let me move that over. I was trying to leave the other graph up for a little while longer. Okay. Here, our line of reflection, okay, is y equals 1. So we're going to go on the y-axis now. And on the y-axis, we're going to go to y equals positive 1. So positive 1 is right here. And I'm going to draw a line through this point. So if I were to draw a line this way, it's not really, it hits, that becomes my y-axis. It's no longer the line y equals 1. So I have to draw a horizontal line through the point. So there is my equation of y equals, or my line of y equals 1. Okay. So then I do the counting once again. I do the counting. Okay. So my A prime, here's A. It's only a distance of 1. So I'm going to go a distance of 1 here. There it is. Here's A prime. Okay. B, start here. 1, 2, 3, 4, 5, 6. No, 5. I'm sorry. 1, 2, 3, 4, 5. Yeah, 5. And then so 1, 2, 3, 4, 5. There is B prime. C, 1, 2, 3, 4. So 1, 2, 3, 4. C prime. Okay. Bam. We have reflected our triangle. Okay. Okay, can I get a thumbs up or thumbs to the thumbs up, thumbs down, or thumbs to the side for these two examples here?
We want everybody to participate with a thumb.
Thumbs up or thumbs down, ladies and gentlemen. Everyone needs to participate.
This means you. It's okay if you don't understand it. Just go ahead and put a thumbs down. That's fine.
Yeah,
No
all I'm
problem.
asking is for some sort of indication
Yeah. Be honest.
that you are here,
Mhm.
that you are trying.
I looked at it for a while, and I was like, wait a minute. Wait, what? And then I just had click. It was like something, my brain went off, 10 seconds later, on. Just-
Okay. You just got to wait for that click, huh? That's good. All right, let's get some participation here, guys. Thank you for those of you that have participated already. Hey, let's get some participation here. Bethany, Caleb, Joe, Joshua, Mariel, Ulysses. There you go, Ulysses, got yours. Okay, thank you. The majority of you have participated, but I want all of us to participate. Come on, guys. Where are we at? Where are we at?
If you don't participate, we don't just assume a thumbs down. We assume you're gone.
Yeah, that's
So-
exactly what I'm assuming. That's why I
Yeah.
mark off for participation points.
Right. So if you don't understand it, just put the thumbs down. It's okay. No problem.
Wait,
But we got to see that you're there.
thank you, Mr. L, for this clarification. Rocking those.
Bethany, Caleb, Joe, let's go. Joshua. Sometimes they zone out. They just have to hear their name.
I know. We've already said their name like what, 3 times, 4
I
times?
know. It's kind of like they're not there.
I know. Okay, I guess we're moving on. Unfortunately, we gotta. I mean, it's not fair to everyone else, right? All right, ladies and gentlemen. So we also have different other lines that we can reflect across, which is the line of y equals x and the line of y equals negative x. Okay, these lines are slanted lines, and they are the lines that like literally go perfectly. Like they have the points like y equals x has the points like 1 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8, like where x is y, x and y are the same thing. Okay, so it would be like this perfectly 1-to-1 slope line. Here, I'm just going to make some markers for myself so I know where to draw my lines and what points to use. So I put the points of 5, 5, and 10, 10 because I know that's on the y equals x line, and -5, -5, and -10, -10 because those will also be on there. And of course, 0, 0 is also on there. And then I'm just going to draw my line here. And this is going to be my y equals x line. Okay, here's my y equals x line. So this would be this line to reflect in, this guy right here. Okay. Now, we don't have the time to do this whole exploration, so I'm just going to give you the rule. Okay. I'm just going to give you the rule here. So just like with the y-axis and the x-axis, we had rules for how our points changed. Okay. We also have rules like that for the lines of y equals x and y equals negative x. So y equals x has a special rule where when you reflect a triangle across the line y equals x, your x becomes your y and your y becomes your x. Okay, so when we reflect across y equals x, our point, our coordinates flip. So the x becomes the y and the y becomes the x. Okay, so what does this mean? How does that reflect here? Okay, so let's take a look at our example here. We have a triangle. Oh, look, it's a different triangle. 5, 2 is A, B is at 1, -3, and C is at 8, -5. Okay, so let's graph that. 5 and 2. Okay, here's A. B is at 1, -3, so 1, -3. Here is B. And C is at 8, -5. So this is 5, 6, 7, 8, and -5. So 1, 2, 3, 4, 5. So here is C. Okay. So with these, counting is not as easy when you reflect across y equals x or y equals negative x. So knowing the rule really helps out, like really, really helps out, okay? So if my rule for reflecting across the line y equals x, if my rule is that each point flips, so the x becomes the y becomes the x, what that means is that up here, reflecting A across the line y equals x means that if A is 5, 2, then A prime is going to be at 2, 5. Okay, see what happened there? The y became the x became the y. So my coordinates flip. All because it's y equals x. Y is x is y. Okay. So for B, if B starts off at 1, -3, then that means that B prime, my y becomes my x, so -3. my x becomes my y at 1. So -3, 1. Okay. Similarly for C, 8, -5, that means this just became -5, 8. So if I graph these guys here, so I have 2, 5. So 2, 5, this is now going to be my A prime. -3 and 1. So -3 and 1. Here is my B prime. And then -5 and 8. -5 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. Here's my C prime. So if I do this and connect my dots, my points here, I can see there's a very nice clear reflection. If I were to switch over my paper like this, so you're looking at this a little bit more vertically, you can see a nice perfect reflection there, a mirror image. Okay. Okay. Now, for this one here, I know I'm moving fast, guys, but we only have 5 minutes left to class, and I do want to give you this other rule, okay? So please, please, please be nice. For the line, a reflection in the line of y equals -x, okay? This line looks a lot like this one, but it's now going in the negative direction, in a downward slope, okay, in a negative slope. So this line has the points of 1, -1, 2, -2, 3, -3. Or if the x is negative, the y is positive. So it would be like -1, 1, -2, 2, -3, 3. So it's going in this direction now. So the points that I'm going to put here for me to graph are going to be -5 and 5, -10 this way and 10. And then over here, I can have 5 and -5. So it's in the x and the y are opposite signs for the points. So then our line is going to go slanted in the negative direction, sloped in the negative direction here. All right. So now for this line of reflection, for the line of reflection of y equals -x, okay? The coordinates switch. They still switch, but they also change sign. So when you're reflecting in the line y equals -x, each of your points flip and both coordinates change their signs. So not only is there a flip, but they're also changing signs. Okay. So for example, here we have our a different triangle here, 5, 2, 7, 6, and 9, 5. Okay. So if I graph our triangle here, 5, 2, this is A, 7, 6. I think this is our old one from the front. And 6 is 9, 5. For C, I'm sorry, not 6. Okay. So to reflect this across the line of y equals -x, I flip the coordinates and change the signs. So not only are we flipping these guys, so not only is 5, 2 now becoming 2, 5, but each one of them changes the sign. So 2 is positive, so this is now a -2. 5 is positive, and this is now a -5. Okay. For B, same thing. Starts off as 7, 6. So now B prime for reflection in the line y equals -x, B prime will become 6 and 7. But not only that, 6 is positive here, so it's a -6. 7 is positive, so it's a -7. Okay. If any one of these were negative to start with, then they would change to positive. That would be the flip of the sign. right? Okay. And then you have 9, 5. So again, flip and change the sign. Positive 9 becomes a negative 9 here for the y. Positive 5 becomes a negative 5 here for the x. Okay. So then if I go through and I graph this, a prime is going to be at -2, -5. So this will be at -2, -5. Here's a prime. B is at -6, -7. So -6, -7 here. Okay, so this will be B prime. And then C prime will be at -5 and -9. -5 and -9 right here. Here's C prime. So I connect those. And there you go. Again, if I make this look a little bit vertical, you'll see that that's like an exact reflection of each other. Okay. You have a very small exit slip, a very easy exit slip. You also have your homework on big ideas. Please do not forget to scan and upload your notes. Everything that I'm assigning you guys, it's easy points. Okay, all you have to do is actually do it. Scan and upload your notes. Do the exit slip. Do the warm up. You do them, you get the points. Okay, simple as that. If you have questions, please come to tutoring tomorrow during 8th period. If you would like to retake your chapter 3 test, again, tomorrow during 8th period. Okay. Other than that, guys, have a great day.
Bye, Miss K.
Bye. Make sure you guys remember to watch the video on Friday.
Bye, Miss Carabin.
Bye. Have a good day, guys.
Bye, guys.
Bye.
Bye. Bye, Maya.